Hey guys, welcome back to the course. Hope that you don't all hate me after the midterm. Let's see. I'm gonna do a poll first. All right, I've launched the poll. Hopefully you can see it. Oh, come on. You don't have to suck up to me either. Not everyone is gonna believe it was just right. Oh yeah, yeah, thrilling, baby. That's what I'm counting on. I want you to be honest always with these. I'm not doing it for any other reason than just feedback on, we want to modulate the difficulty. All right. One person thought it was too easy. That's Kusema, that's pretty funny. Um, okay. Well, that's very interesting. Let's see. Let me just That's pretty good. Let me just see something. Okay. So most of you thought it was just right or thrilling. Three people thought it was too hard. I'm gonna double that number because it's like in the movie American Pie, you always got to double the number of the thought it was too hard. And then one thought it was too easy. Okay, let me do. One more poll. Let's see, and okay. All right, we have a near unanimous decision. So I am happy because I do want to solve the midterm. Now, I hope I don't make mistakes. It's always the fear. And I have not prepped for this at all. But I am going to solve it. All right, let me just load it up. And then I will go through it, annotate my screen. Okay. It's a bunch of people missing. I wonder if it's just a circuits midterm hangover. Question. You're all winners. And the top 5 people are getting a prize. I'm just working on, it's a public institution, and so anything requiring money is, you gotta jump through hoops of fire. But no, you're all winners though, especially in my eyes. This has been one of the, actually, objectively, this is being recorded. I guess maybe I shouldn't say this, but this has been one of my favorite years for the course. It's a shame that we don't get to meet in person, because I think it would have been a lot more fun. Okay, let me just load up the midterm. Where is the midterm? Oh, I guess I can just go to Blackboard.
Professor,
What's up?
on average, when do we get our results back?
Very quickly, I'm gonna talk to, so the way the multiple choice and short answer get graded like automatically. And then what I'm gonna do with I think my plan for the problems is I'm gonna have, you don't want different people grading the same question. But I'm gonna have Tariq do one question, and I'm gonna give them explicit guidelines for how I grade. And I'll tell you in this lecture how I grade. I'm gonna give Sam one question, and I'm gonna do the other two myself. And that way, um, each student will have every question graded by the same individual. Will next fall be in person? Well, so first of all, the answer is no one knows for sure, but the plan is to be in person for most classes. And I actually believe New York City has a good chance because of the vaccination rate has been very high. So, you'll get to, I think there will also be a lot more flexibility in terms of online learning, but the plan is to do it in person. But this virus is it's a unpredictable situation, so no one really knows. Okay, so this is me doing the midterm. The law of conservation of energy must be obeyed in all circuits, only linear circuits, or neither of these two. So energy must always be conserved. So I think most of you got that all circuits have to obey, it's basically KVL, or conservation of energy. A current direction arrow is oriented left to right, right? So the situation that we're dealing with is the following. And the value of the indicated current is -5 amps. And so the positive charge in this case will actually move right to left, because the positive charge, so the value of the positive charge is -5, reference to this arrow. So reference to this arrow will be positive. So the answer is left to right. Sorry, right to left. All right. Power is a blank function of voltage. So power is equal to V squared over R. Okay. So a linear function would be something of the form power is equal to AV plus B, right? This is not the case. And constant function would be power is equal to K. This is also not the case, which means that the answer has to be C, nonlinear. Go ahead with your question, Kuzuma.
Yeah, that question confused me because I remember, because the first equation I thought of was power is equal to V times I. So that's why my first, when I put my first answer was linear. And then I saw that there's the other equation which V squared over R, and then that just confused me. I was just wondering what how would I have supposed to know that I would say that power is supposed to be a non-linear one of voltage.
Right. So, right. Let me just write some text. So the reason, so if you have power is equal to V times I, right?
Mm-hmm.
The problem is that I is equal to V over R. So this would be linear. This would be a linear function if I was a constant, right? But I is not a constant. I actually depends on V. And so you cannot use this equation to answer this question, because I mean you can, but you have to stop. You have to substitute this in for I, right?
Oh, I see. So you have to fully
I'm
substitute in every
sorry. Yeah,
I.
no, I understand. I understand, but yeah, you do have to. It has. The point is a linear function. The thing that's multiplying the voltage has to be constant, but I is not a constant. It's very much a variable, and it depends on V.
Okay.
But I mean, I hear you. I hear you about what your thinking was.
Thank you.
I always look at the analytics, like, whenever, like, if, like, there's 32 of you in the course, or 34, if 33 of you got selected linear, then that's a clear indication to me that that wasn't a fair question, right? I'm very much a believer in wisdom of the crowd. So whenever I encounter, and I'll see this in the grading, whenever I encounter a situation where the correct answer is not the one that was obtained by the majority of the class, that definitely is information that I have to use. And I have gone back and disqualified questions on that basis. So I don't want to say anything right now, because I want to wait and see what the answers are. But if it's that, if we get into a scenario where where the majority of people got the question wrong, it's a signal to me that the question may not have been fair. All right. Before I answer this question, technology is great. I love calculators. However, they are really not needed for this question or for question 10. So it I fielded way too many questions about calculators that were not warranted. And that's, again, like, we all become dependent on technology. I'm dependent on my pager. I'm just kidding. I do actually own a cellular phone. It's kind of like the one that Borat has. And so I understand you like your technology, but this does not need a calculator, right? So I won. And the reason it doesn't, because you don't care about the absolute values. You only care about the proportion, right? So I1 is going to be equal to 10 over 10 plus 5, right? So 2/3 of the current goes here, because 2/3 of the resistance is here. So 2/3 of 27 18. No calculator needed. You don't need to know anything about milliamps, kilo ohms, nothing like that. You just need to know what 10 over 15 is. So the answer here is 18 milliamps. And I mean, I can do it, for I2, it's the same thing, except this is 5. And then this will be 9. So 1/3. Right. So yeah, that's all there is to it. So 2/3 of the current goes here because this has 1/3 of the resistance, and 1/3 of the current goes here because this has 2/3 of the resistance. Sorry, yeah, this has 2/3 of the resistance. You get it. Just current division. So the answers are, I know one of you, this is getting recorded and this is going to be posted on Course Hero or something. Anyhow, yeah, so I think most of you got this right, actually. I had a kind of a quick glance. All right, you guys jump in with questions anytime you want, or if you want to boo or cheer the questions, that's fine too. Question 5, when applying the technique of superposition and removing a voltage source, we replace it with, right? So what does it mean to remove a voltage source? It means make the voltage 0. Making a voltage 0 is equivalent to a short circuit. So current source would have been for source transformation. An open circuit would be if you were removing a current source. Right? So when applying, you turn a battery into a short circuit. The 2 input terminals of an op amp have approximately, right? So let me draw this out. I think this one, part of it is just that it's awkward to answer these, to pose these with words, like, so you have, oh, let me actually, right? So the op amp assumption is that this is V1, this is V2, this is I1, and this is I2, right? So basically the op amp has such a high input impedance that it doesn't draw any current in because the current avoids the inputs of the op amp, right? So I1 and I2 have to be 0. So we definitely want the 0 current. Because V1 and V2, because if you have one point here and another point here, and they're connected by a super high resistor, there's not going to be any current flowing between these two, and therefore they're at the same voltage. That voltage does not have to be 0, but it does have to be equal. And so the answer is that first one, 0 current and equal voltage. And hopefully you got that. Which theorem states that a linear 2-terminal circuit can be replaced by an equivalent circuit consisting of a current source in parallel with a resistor, right? So that is the definition of Norton's theorem. You're welcome. An operational amplifier behaves like a current-controlled current source, a voltage-controlled current source, a current-controlled voltage source, or a voltage-controlled voltage source, right? So if you think back to how when we first taught op amps, it looked something like this, right? You have V1 and V2. These are your inputs, and they are separated by a large input impedance, right? Right. And then at the other end, this is, I don't know why I drew a triangle, it just felt fun. And then at the other end, you have a very large ground symbol. And then you have a voltage whose value is equal to A, V, VD. In parallel, sorry, in series with a resistor. Okay. 50 ohms generally. And so VD is equal to V2 minus V1, right? And so this voltage here is voltage dependent, voltage controlled, and it is a voltage source, right? This is op amp is producing a voltage that's dependent on another voltage. And therefore the answer is D, voltage controlled voltage source. All right, moving along. This was straight from the Kahoot quiz. What kind of an amplifier circuit is this? So here we have two sources, right? So you know that it's not inverting, and you know that it can be inverting, non-invert. It can be inverting or non-inverting because it has more than one source. It's not a summer because both the two inputs are not on the same, are not connected to the same input side. This is a difference amplifier. This is just a picture of an arbitrary difference amplifier, because if you were to work out the KCL equation, you would see that this output V naught here, just write it out. This output V naught is going to be equal to, let's just say, A times V2 minus B times V1. So it's going to be a weighted difference of the two inputs. So this is a difference amplifier. All right. And then the last question in the short answers, another example where you definitely do not need a calculator. All right, so let's work this out. Voltage division, right? So V1 is equal to what? This is our battery that gets divided up into two parts, V1 and V2, right? So V1 is going to be equal to 6 millivolts times 10 kiloohms over 10 plus 20, right? So 1/3 goes to V1 and 2/3 goes to V2. So for V2, the only difference is this becomes 20, right? So V1 is equal to 2 mill. Again, the milli and the kilo don't matter here. This could be pico, nano, femto, whatever. It doesn't matter because it's just proportions that you care about. And V2 is equal to 4 millivolts. All right. This is 2 and this is 4. All right, so that wraps up the short answer and the multiple choice. And so when I look back at this, I'm going to see what the average was out of 25, but I'm guessing it's going to be close to about 20, I would say, hopefully higher. All right, now we get to the good stuff. So let me try to think of which one of these. I guess the third problem was probably the one when you see the solution, you often realize that it's actually not hard, but I consider the third problem. The first and third problem were probably the most challenging. Let me just first draw this. So I told you guys that there's going to be a super node and a super mesh. So you knew that going in. So the super node here is connecting node 1 and node 3. It does not connect node 2. I think that's a common mistake, is that people do something like this. They try to make a super node. It's not necessary here, right? The super node is just okay. So this is the super node here. There's nothing in parallel with it, right? This is not in parallel with it because of this current source, and this is not in series with it because of the current source. And all of this is also not in series in parallel with it. Can we get partial credit the people who thought the 2 node was connected with node 1 and node 3? Yeah. I mean, that's what I have very strict guidelines for, and this is one of the hardest things in grading, is how do you handle when you make the wrong assumption at the beginning of a problem. I remember one of my midterms in grad school where I just applied the wrong assumption at the beginning. I just got 0 for the question. I mean, I'm not gonna do that. Let me work through the solution, and then and there are gonna be a bunch of you that super noted probably all of this. But let me work through so you have 3 nodes, right? So you have node V1, V2, and V3. So you have to write a KCL equation. You have to write 2 KCL equations and a KVL for them. You need 3 independent equations. So let's draw the current arrows. We're going to go down. I was going to draw all the currents leaving the supernode, right? So this one's leaving. There's 4 currents. This one's leaving. This one's leaving. And this one's leaving, right? So that one is going to be V1 over 4 plus V1 minus V2 over 2 Go ahead, Omar.
I just had a quick question. If we drew our like currents in other directions, like I drew them out of the current source rather. So like it went up and then one left, one right, and then down and down.
Oh yeah, that's you go as long as you as long as you're obeying Ohm's law and KCL, you're getting at 100%.
Okay, thank you.
There's no I don't care which way you write them. There's like 4 to the power. There's like what? How many different ways are there of doing it? 2 to the power of 4. There's 16 different ways of writing this, right? And so you're not going to all write in the same order, and that's perfectly fine. So this V1 minus V2 over 2 is this current. V3 minus V2 over 2 is this current. And then this current here is just V3 over 8. And that all has to equal to 0. Let me just see, is there a question? Is there an intuitive way of knowing which direction the current? No, there really isn't. I mean, the reason you can is because the voltage can be positive or negative. So there really is, I mean, it's just whatever your personal preference is. Hold on a second. So like, I like to draw if there's ground down here, I just always draw the current arrow going down. But in terms of these, there's really no way of knowing which way it's gonna flow. I guess this current is going up, so like it may have made more sense to draw it exiting this node, so the opposite of what I drew, but it really doesn't matter. At the end of the day, the only thing that I care about is that at the supernode, you first of all, you identified 4 currents because there are 1, 2, 3, and 4, and that you made the correct Ohm's law substitutions. That's really all I look for. Like if, for example, one of these minus signs was incorrect, I'll dock like 1 point out of 25 or something. Like it's I really am trying to evaluate just whether or not you use the right principles. So that's equation number 1. I'm not going to simplify it here. I'm sure you know how to simplify. Here you would just multiply everything or whatever. Let me just do it actually. So we're gonna multiply everything by 8. So 2v1 plus 4v1 minus 4v2 plus 4v3 minus 4, and correct me if I make a mistake here, plus here. So let's add it up. 6v1, is that right? How many v2s? Minus 4, minus 8. And then 5 v3s. Oh. Okay, so this is our KCL equation for the supernode. Okay, we're gonna move now to the KVL equation for the supernode, which is much less work, right? We have a 10-volt battery that separates nodes 1 and nodes 3. So by definition, node 3 has a voltage that's 10 volts higher than node 1, which means that V3 minus V1 is equal to 10. So that's our second equation. So we're 2/3 of the way there. And then our last equation is going to come from KCL at this node, right? So we have 5. We're going to again draw. Let's do the follow. Let's keep our current direction convention from the previous steps. So we're gonna draw all 3 currents converging onto this point. In other words, the sum of these 3 has to equal to 0. So we have V1 minus V2 over 2 plus V3 minus V2 over 2 plus 5 is equal to 0. And then let's multiply everything by 2. So we have 2v1 minus, oh, oops. V1 minus V2 plus V3 minus V2 is equal to negative 10. And so we have V1 minus 2V2 plus V3 is equal to negative 10. Oh, does of course annotation. So all I want to do is put the box around this equation. Okay. Let me just see what the chat, there's a chat question. 5 amps is entering node 2. Won't that be negative? They're all entering. And so they all have to sum up to be 0. Right? So this current plus this current plus this current is equal to 0. And those are your 3 equations. Okay, I think, I don't know, I think this question is the right level of difficulty. Uh-oh. If we had the same answers but opposite signs for all numbers, yes, that if same number, if every coefficient was negative, that's 100% correct. That's not the only way to draw the arrows. No, you can draw the arrows many different ways. At the end of the day, as long as you're when evaluated, if your equation would have given the same numbers, you get 100%.
I have a question.
Go ahead.
So I did the arrows the other way, but I also substituted V2 minus V1 over 2 plus V2 minus V3 over 2 as 5. So all of those going into the super node I just wrote as 5. Is that fine?
Sorry, can you repeat? So I missed exactly what can you try to restate your equation?
Yeah, so I did the arrows the other way from node 2. So from
Okay.
2 to 1 and 2 to 3. Instead
Right.
of doing V2 minus V1, I just basically summed those two and said that
Right.
5 is going to the super node. So for your first equation, I just
Oh,
have like a
I see. Yeah, so you would have had 5 is equal to V2 minus V1 divided by 2 plus V2 minus V3 divided by 2.
yes, that's correct. And I
That's
substitute that into the first equation. So instead of the long one, I had like a different one. That should be the same, right?
Yeah, I just like but as long as you wrote down the equation that I just stated and you wrote down the original KCL equation, the supernode, then you get it, then you would get full points.
Okay, thank you.
You're welcome. The thing I'm looking for are the 3 independent equations. Go ahead, Akuzama.
So for your second and third equation,
Yeah,
I got that, but all of my, what's it called, the signs are reversed.
everyone is reversed.
Yeah, so
Then you
instead of,
still get
instead of,
100%.
yeah, so I got like V1 minus V3 equals minus 10. Yeah, it's just the signs are reversed for the last two.
Yeah, that's fine. If you can multiply the whole equation by -1 and that doesn't change anything, it's still valid.
Got it. That's just what I was worried about. Thank you.
No problem. All right. Just make sure I've answered all the chat questions. All right. Let's move on to this question. All right. This one I haven't done in a long time, so I hope I don't screw it up. Okay. So here we have a super mesh. Between meshes 2 and 3. Okay. And so let's start by writing the KVL going from this point, going clockwise. Right. All righty. Let me actually switch to text to make this a little bit less painful for you guys to witness. So A times I2 plus 2 times B naught plus 4 times I3 minus I1 plus 2 times let me just double check this. 8I2 plus 2B naught plus 4I3 minus I1 plus 2I3. Now, of course, that's we're not done. We have to define what V naught is. V naught is going to be equal to 2 times I2 minus I1. Oh, check that. Because the positive pole is here, and so I1 is entering the positive pole, and I2 is entering the negative pole. So now substituting that in, we get 8 times I2 plus 4 times I1 minus I2 plus 4 times I3 minus I1 plus 2 times I2 minus. Go ahead with your question.
Professor, if that's the case for the 2 ohm resistor, couldn't we have said the same for the 4 ohm then? Wouldn't it be I1 minus I3, seeming that the positive would be on top and the negative would be on the bottom?
Yeah, it's a good question, but in this case, we're going around, we're looking at the drop. Yeah, it's a good question, but the drop from this point to this point is equal to 4 times I3 minus I1 because let me just draw. So this is positive and this is negative when you're doing KVL in this loop. We just double check that my equation is correct. So, oh, someone's had enough. 8I2 plus 2B naught plus 4I3 minus I1 plus 2 times I2. So that seems right. And then V naught is going to be 2 times I1 minus I2. So let me try evaluate this now on the fly. So this will be what? So let's count the I1s first. So we have plus 4, minus 4, minus 2. So this is all unofficial because I'm doing it. Now let's count the I2s. 8 minus 4 is 4. Plus 2 is 6. And let's do the I3s. 4. Check 4. Okay. So that's the equation. That's the first equation here. The first of 3 that you need to produce. And the way I usually grade this is there's 25 points per question. And so basically, if you get 1 out of 3 equations, you get 9 out of 25. If you get 2 out of 3, you get 17 out of 25. And if obviously if you get 3 out of 3, you get 25 out of 25. So I gave you the extra point. just because you guys are all winners. Okay, so now moving on to KCL at the supernode. So we're gonna focus this node here, right? So we have I3 going up here. We have I2 escaping up here. So we're gonna have I3 flowing in is equal to 3 plus I2. Okay. So we have 2 out of 3. And the last KVL equation is going to be going this way. So let's start again at the top left and work our way clockwise. So we're going to have 2 times here. I1 is entering the positive node. Plus times minus 12 is equal to 0. Right, because this is a voltage rise. And so the equation is going to be 6 times I1 minus 2 times I2 minus 4 times I3 is equal to 12. Right, so you see that there's similar coefficients as in the first. All right, so this is the third and final equation. Here, this one. Okay, go ahead. Did I make a mistake?
No, I just wanted to say, I made that slight little mistake in the first equation. Like, I mean, when identifying VO, I substituted 2 times I1 minus I2, but in the equation when doing KVL, I did I2 minus I1.
Yeah, I mean, you're gonna lose some points. You're not gonna lose a ton of points, though. You know, I don't know. I don't know. I don't want to answer on the fly, especially because I'm getting recorded. But you're not gonna lose a lot of points for that. That's especially if you produced. Like, there's 2 considerations. If you had not made that mistake, would you have arrived at the right equation? And then the other thing is, were your other 2 equations correct? You know, so that's the answers to those questions is going to determine how many points you get. But if it's just that, it's that you're not going to lose that much.
Okay, thank you.
Don't worry. Okay, let me just I simplify the equations further. Yeah, that's fine. Right. That's perfectly fine. Of course, that's okay. So you can multiply all these equations with a fraction. And then get that. That's perfectly fine. 100% for that. All right. This is my favorite question, probably your least favorite, but actually when you see it, it's not a lot of work.
Me too.
Yeah. Yeah, thank you.
Actually, like on Tuesday when I sent out the Slack message, I forgot to send out an email announcement to you guys. If you guys came to the review session on Friday, I would actually went through this problem.
Nice.
So yeah.
Yeah, I like this one because it makes you think, but it doesn't actually require a lot of manipulation. So let's first do the RTH. All right, so let's do. Oh, oops, I don't even need this. RTH, we're gonna get rid of the current source. We're gonna open circuit the current source. And what you're gonna be left with, and I think most of you were able to reproduce this picture at least. Oh, oops. Sorry. Let's try again. Okay, so this is 10. $20. Excuse the chicken scratch. 50. And 40. So the way and so the way to think about this is the following. To get from point A to point B, what are the possible paths? So path number one, okay, let me answer this question first. Yes, Christian, you're correct. So path number one, oh, I don't want to clear the drawings. So path number one is this way, right? That's path one. And how much resistance do you encounter taking that path? Well, you encounter 10 plus 20 because the 10 and the 20 are in series along this path. All right, so this is 30. The other path is to go this way, right? Which is 50 plus 40, which is 90. Right? So to get from point A to point B, you either take this route or this route. And those routes are in parallel. That's the key thing. So the RTH, so the full, actually, I can do this with text. Oh, I didn't want to do that. Redo. Undo. Okay. No, I'm just gonna do text here. So the RTH is equal to 10 plus 20 in parallel with 50 plus 40. RTH is equal to 30 in parallel with 90. RTH is equal to 2700 divided by 120 is equal to, let's see, is that right? 22.5 ohms. Right, so I believe this is 22.5 ohms. All right. Let's see, chat question. So yeah, so it's 30 in parallel with 90. Okay. Go ahead, Omar.
So for this, I actually manipulated the diagram to make it look like how we worked with Thevenin first, and then did finding RTH and all that stuff.
So, but how did you find our RTH?
So at first I manipulated the equation, then I just put an open circuit for the current source.
So the open circuit for the current source is good. I guess I'll have to look at the,
because it's the same thing as you, like I got where 10 and 20 were in series, but in parallel with the 50 and 40. And I got the same exact answer, it's just I manipulated the circuit differently.
I'm just showing you guys one solution. I'm not showing you the only solution. There's always with circuits.
You kind of cut out a little bit there.
Yeah, I pay a phenomenal amount of money for this internet. and I am really unhappy. If I cut out, I'll be right back. Can anyone hear me?
Yeah, we can hear
Yeah,
you
Professor.
now.
Okay, good. Sorry, I can't believe I live in a small apartment, pay a fortune in internet, and I still have these issues. I even bought a repeater to extend the signal. I blame Zoom. Okay. So yeah, what I was saying is that I'm showing you guys one solution. Like the answer, numerical answer has to be the same, right? To get full credit. But there's more than one way of arriving at the final answer. Okay, RTH is 22.5 ohms. So now let's do the second part, which is what's the voltage difference here between V, A, B. Okay. So I think one of the reasons for confusion is I think people think that this is like there's like a current flowing here. This somehow, at the end of the day, the circuit looks like this, right? You have your current source and you have basically like that, right? If you saw that picture, it wouldn't look as daunting, but just simply by saying that it's like we're putting our voltmeter between this spot and this spot, but it doesn't change the circuit. It's not like, what's that principle from physics? Heisenberg's principle, where if you detect, if you insert a detector, it changes the measurement. That's not true here. Yeah, so right. So it's actually the circuit
Professor,
go ahead.
can we just say like, because the way I saw it the way you drew it the second time, and I was like, I'm just like Thevenin current is basically Thevenin voltage is basically the voltage between this point and this point. So that's how I
It is.
pictured it.
Yeah, it is. Thevenin voltage is just the voltage difference between this point and this point. And so the key insight here is to know that there's an equal amount of resistance on each of these paths. There's 10 plus 50 ohms here. So there's 60 ohms on this branch, and there's 60 ohms on this branch. Right? So in other words, each branch is offering the same amount of resistance, which means that each branch has the same amount of current. Right? And so there is 4 amps going this way. And there is 4 amps going this way. Right? So that's insight number 1, right? And that's just from current division. Each branch has an equivalent resistance. So the current is getting split equally into 2 parts. So now this voltage here is ground, right? So that's sitting at 0 volts. So then what is the voltage of this point here? Let me ask one of you guys. What is the voltage of this point?
Is it 40?
40? How did you get 40?
4 times 10.
It's a good guess. It's very close. It's actually 200. It's actually 4 times 50.
4 times 50. I was
Yeah.
contemplating between both of them.
That's okay. You're gonna get partial points.
No, the way I did that, I actually did mesh analysis. And using mesh analysis, I found the current in the second mesh, and then I found the voltage of the 10 volt. I added it to the 20 volt. But I did a mistake because I should have considered the direction of the currents, like the direction of the general current, which I didn't. So instead of doing 80 minus 40 to get 40. I added them.
Okay, I mean, I'm gonna go through your solution and just, I obviously I want everyone to do as well as possible. And so I'll hopefully you got a lot of the key parts in there. How is it 200? Yeah, so the reason it's 200 is, so there's a voltage drop by Ohm's law. The current flowing through the 50 ohms is 4 amps. And so voltage is current times resistance. So 4 times 50 is 200. So there's a drop of 200 volts from here to here. And this point is at 0 volts. So 0, it gets down to 0 and it drops 200. So it had to drop from 200. And then similarly, this point here is sitting at 4 times 40 ohms, 4 amps and 4 ohms, which is 160 volts. Right, so the Thevenin voltage which is equal to the open circuit voltage across A and B is equal to 200 minus 160, which is equal to 40 volts. So the Thevenin voltage is 40 and the Thevenin resistance is 22.5. Okay. If there's any questions, please chime in. Otherwise, we will move on to the last problem. Okay. So the op amp question. Go ahead, Andre.
Professor, I did like a very classic rookie mistake of calculating the equivalent resistance wrong, but I ended up getting, through mesh analysis, it would have been the right answer of 40 volts at the end. Would I still get partial credit from that?
So how does the can you clarify what your mistake was exactly?
So I did get the understanding of the 50 and 40 in series, which is parallel to the 10 and 20 in series.
Okay.
I don't know what I did in my head, but I added it wrong for some reason, and I just got a wrong equivalent resistance value.
When you say you're talking because
the RTH, I'm sorry.
I mean, they're graded separately, right? So like they're so if you would have said, for example, that RTH is equal to 10 plus 20 in parallel with 50 plus 40, but somehow your math just ended up being wrong, you still would have gotten most of the points. But if you would have said that the RTH is 10 plus 50 in parallel with 20 plus 40, then you would lose more points, right? So if it's just an arithmetic error, it's not a big loss. But if it's a conceptual error, it is a big loss. Hope that makes sense.
Yeah, it was just an arithmetic error because then I just carried that through to find the open circuit voltage.
Oh, I see. So you used the solution from RTH to get VTH?
Yeah.
Okay.
Through mesh analysis.
I see. Okay. I'll have to look carefully at your solution, but I mean, we're not going to double penalize you.
Okay.
Yeah.
All right. Thank you.
No problem. All right. Op amps. This question is my gift to you. You may not have opened the gift box, but it was my gift to you. It's really not bad. Thank you, Sergio, for not making me feel crazy. All right. Thank you. More support. I love it. Thank you for making your favorite question. Yeah, this one's nice. This one is like logic. It's like a puzzle. That's what I like about circuits the most. It's really like solving a puzzle. You just kind of got to go step by step. So this point here is 5 volts, right? Because this is 0 volts. By the key thing is here, that voltage magically ports over to here, right? So this is also 5 volts. So there's a 5 volt here, and there is a 2 volt rise from here to here. What does that mean for the voltage of this point here?
3 volts.
Yep,
Oh God.
exactly.
Oh.
3 volts.
So VO is basically 3 volts.
Yep. And that's all you have to do, right? It's just 2 steps, because that voltage it's all here, right? So it's just equal to 3 volts. Okay. So that was so again, this is 0 by definition. This is 5 by definition. By the ideal op-amp assumption, the 5 volts appears here. And then there's a 2 volt drop from here to here. So this is 3 volts. And then that voltage just propagates all the way over to the output. And then now what is the current through the resistor? Well, this end, this is V naught. And this is 0, right? This is 0. Right? So the current is equal to V naught over 2 kilo. So this is another question where people asking for calculators, you don't need it, right? It's just 3 to, like, if you just wrote 3 over 2000, that's fine with me, but it's really just 3 over 2 divided by 1,000, right? So it's 1.5 milliamps, but if you just wrote 3 over 2000, that's fine. Okay. All right, we have a question. Yes. Because I said no calculators, I'm okay if you just leave it as 3 over 2000. All right. Yes, another midterm in the books.
I have a question, Professor.
Go ahead.
Because when I saw this, like, I understood op amps, but I just didn't get the part. I was contemplating of choosing it or the 701 just because I know that the 5 is going to be equal to 5, or how it's going to interact with the 2 volts.
Mm-hmm.
Like, I thought that the 2 volts will like, I just got like, I didn't get the concept that it's 3 volts added to 2 that will give us a 5 volt.
Did you attempt this question?
In my mind, yes. On paper,
I mean, in
I wrote the
reality,
circuit. I wrote this. I drew the circuit, and I tried to like just see how the 2 volts is gonna interact with the 5 volts.
I guess what I'm asking is,
that
was this one of the 3 problems that you answered?
no,
No,
I
okay.
didn't put this in.
Okay.
Well, I was, because it's easy. I just got confused because I thought the 2 volts, how is gonna the 5 volts be equal to the 2 volts? Because I thought the 2 volts should be at the node.
Oh, that's only true if the bottom is grounded.
Okay.
Right. So the answer to your question, though, which is how it would interact, is the following. So this symbol, all it means is that this node is always 2 volts higher than this node. That's all a battery is.
Okay.
A battery is just
Okay.
a device that guarantees that its terminals are at a fixed voltage difference.
Makes way more sense now.
Yeah, it
Because
kind of is like
yeah.
a follower, yeah. Yeah. For question 13, I solved it differently, but got the same answer. I used Norton's theorem to find IN. And from there I found VTH by multiplying the IN with the RTH. Yeah, that's fine. As long as if you did it correctly, then and got the correct numeric answer, then everything will be, you get full credit. Like I said, I'm only presenting one, so I cannot, there's an infinite number of ways of, well, maybe not infinite, there's many different ways of solving these problems. And I'm just giving you the way that comes to mind when I look at it. But yeah, as long as you follow circuit laws, then you will get the correct answer. Then you will get full credit if you arrive at the correct answer. No problem. Is there any other questions on the midterm? Okay. Time for one more poll. Give me a second here. All right, let me just, it logged me out of Zoom. Seriously? How insane is that? I'm on the call. Here comes the next poll. Yeah, well, nice. It's a race. All right. We're gonna go by Senate rules here. So we need a 2/3 majority. No filibuster. All right. I'm with you. Everyone's answered. Yeah, so like I said, I'm gonna, Omar, go ahead.
This is more of just something for me. Like, I don't know if I'm being anxious or not, but when I'm looking at the exam, I can see the answer choices to the multiple choice, but I can't see the documents that I attached to the short response at the bottom. Is that just the Blackboard thing, or did it not attach for some reason?
No, so let me just say to everyone else that if you guys want to, if you have questions, stay on. Otherwise, you're free to go, and we will continue the material next Monday. And Omar, stay on. I'm gonna check your solutions.
Professor,
Yes,
does that mean lab is starting on Monday?
I hope so. Yeah, I'm gonna talk to the TAs. Oh, but
Right.
the lab will be at home this year, so you're still coming to class every day and learning stuff from the slides.
Okay. All right, thanks.
No problem. Okay, Omar, take a look at your midterm.
Professor,
Yes.
I just wanted to say I had the same question as Omar, but I asked you immediately after I submitted my exam, and you said that you could see everything.
Yeah, and Omar, I can see you answered 11, 12, and 13.
Yeah, okay. Thank
Yeah,
you.
you're good. Excellent work. Yeah, so don't worry if you can't see your attachments. They're there. You guys enjoy the rest of your day, stay safe. And I'll see you next Monday.
Professor?
Go ahead.
Yeah, I remember I put the right answer for number 10, but I got it wrong. Could you just check what I put for number 10?
I can check. Can I just get your name? Oh, hey,
Yeah,
Jin.
yeah.
Hey, Jin. I got you. Sorry. Let me take a look. Oh, this could be a K, and this is for numbers 4 and 10. I do check them because, sorry. If you put in like the units or something into your box, into your fill in the blank box, then if sometimes it will grade you wrong, but even if you got the right answer, so let me just check. Oh yeah, you wrote in the units. You'll get those right. You wrote in millivolts. But yeah, you'll get 4 out of 4.
All right, thank you.
And that's going to be corrected. It's because it just tries to match up the number, but if there's anything else added to it, it marks it as wrong, but we can obviously override that.
All right, thank you so much.
No problem.